Okay, chapter 6, files. So we're going to be talking about how to work with files, why we would work with files, and specifically how to work with them in Python. All right, here are all the topics that we'll have to cover. All right, so once you start working with programs that work with large amounts of data, you must have to store that data somewhere. Because if you're just working with data that's coming from either a file or a website, it still needs to be stored somewhere once you do certain things to it. And vice versa, you have to take that data from somewhere. So usually it will come from a file or from a database. Now, you can, almost in every single programming language, you can perform certain manipulations when it comes to data and either retrieve it from a file or write it to a file. So two main actions that you can perform is either writing data to a file, which means that you're going to save some sort of data to a separate file that's on your computer, or you can also read data from a file. And that just means that you're going to retrieve some data from that save file. So either you're going to put something to that file or take something from that file. And there's a couple of terms that come with it. So whenever you're writing data to a file, the file that you're writing that data to is generally referred to as the output file. And whenever you're working with getting some input from a file, that's what we call the input file. So every data that comes from a file that you are retrieving it from, that file is called the input file. Now let's go back. So this is the general, just a little diagram that is easier, just makes it easier to visualize how the data is stored on a file. And this is a disk. So whenever you store data to on a file, this is generally what it's going to look like. Obviously not it's not identical to how it's stored, but it's just so it's easier for us to understand how this whole action is happening. So we have a variable pay rate, employee ID, and employee name. Now, all of these variables have some sort of values assigned to them. Pay rate is 1865, employee ID is this number, and employee name is Cindy Chandler. So it will generally be stored on somewhere on this file right here. And whenever you're writing data to a file, it will be put into an empty space that exists inside of your disk or inside of your file. Now, when it comes to input file, there are it's gonna be the same idea. However, you're gonna be retrieving it. So everything that's stored on a file, you can retrieve it from that file and store it into a variable. So for example, if we had all of these values already stored on a file, you can easily retrieve them and store them into their respective variables and variable names. However, there are three important steps whenever you're working with files. And those steps are, you have to open the file. After that, you have to do something with the file, do something with that data. That's either you're going to write some data to a file or take some data from a file. And the last step, the most important one, you have to close the file. If you do not close the file, there's going to be a lot of problems. You're going to leave a lot of vulnerabilities in your program. And if you do not do that on a larger scale, you might open a lot of security issues, and your program might be very, very vulnerable to any attacks coming from the outside. Now, there are generally just two types of files, and we're going to focus on just two of them in this course. It's a text file. It's just data that has been encoded as a text. So literally all that you see in your notepad, Word documents, that is a text file. And there is a binary file. A binary file, it's data that has not been converted to text. So zeros and ones or ASCII values or what are they called? Hexadecimal numbers. So anything that has not been converted to a text yet, that's what we call a binary file. There are two different ways to access that data that we store inside of the file. They're pretty easy, two easy concepts. So the first one is sequential access. So you are sequentially accessing every single element that exists in that file. You cannot skip, you cannot jump from beginning to end. You have to go through every single file, every single piece of data that exists in that file from the beginning to an end. However, direct access is the complete opposite. You can jump directly, that's where the name comes from, direct access. You can jump directly to any element that exists within that file. So if you just need to retrieve one element in the middle of the file, you can do that with direct access. It really depends on how the data is stored in that file. And usually while you're working with files, you will know, it will be provided to you how the data is stored in that file. So if you see sequential access, just know that you cannot skip through any elements. You have to go from beginning to an end. And if you see that the data has been stored as with the usage of direct access, just know that you can access any element at any given time. File names. All right, so file name extensions, you are familiar with those. For example, .jpeg, we know that those are pictures. .mp4, we know those are videos. You might have seen MP3. That's when Spotify was not a thing. MP3 was a way to store music on your phone or on your laptops, and so on and so on. .txt, we know that that is text. So those are file names extensions. So when you look at the file, you will know exactly what's stored inside of it if you know what those extensions mean. Or the same way, PDF, we know that that's some document, right? PowerPoint is, I don't quite remember, PT, something like that. You know, the PowerPoints are a certain extension. Excel files also have their own extension. So there's a big variety of those extensions. You just need to know what those mean. And the more you're working with files, the easier it's going to be to recognize what those files are. So it's just going to come with time. Now, file objects is a little bit different. So think of it as a variable to store your file in. So whenever you're working with files, we can't just say the name of the file and say that we're going to work with it, right? You cannot do that because your computer will be very confused. You're going to send the name of the file and the computer will be like, I don't know what to do with it. So that is where file objects come in. This is a way for your computer to work with those files that you're going to be working with. Now, here's how it's going to be. So a file object is going to be referencing some sort of file. So a file object, for example, let's say this is everything that we are storing inside of our file. So a file object will reference everything that is inside of a file, and then you will assign that file object to a certain variable name. And I will show you an example of that. This is how you will open those files and create a file object. So there are three modes to opening a file. Reading only, that is when you want to retrieve some data from a file. Remember, input file. If you're working with input files, you will use this mode, R. It stands for reading only. Now, W is when you want to write to a file. So if you have some data that you want to be written to a certain file, this is the way to do it, writing mode. And appending mode is the same idea as the writing mode with a slight difference that we're going to focus on in a little bit. Now, open function, that is how we open a file. We're going to create a file object, and that file object will reference a certain file on your computer. The way to do it is to put the name. It doesn't have to be file object. It can be whatever you want it to be. It can be just file. It can be opening a file. It doesn't matter. It's up to you, the name of your file object. Then you will put an equal sign with a keyword open. The keyword open will tell your computer that you want to open this file. Then inside of the parentheses, you're going to put the name of the file that you want to open in quotation marks. So for example, let's say example.txt. txt, that's the file that we want to open. Then you're going to put a comma, and then you will specify with which mode you want that file to be opened. If you want it to be open only to retrieve some data, you will put R. If you want to write some data to this file, you will put W or A. And I will tell you the difference between the two. All right. So if if your file name does not contain a path, and the path is usually, you're probably familiar with it, you saw it multiple times if you have been on your computer recently. It's like your C disk, C drive, something like your username of your computer, Sonia slash, and the name of the file, for example, example txt. That just means that will specify to your computer, this is the path to find this file inside of your computer. If you do not specify this path, if you just specify the name of the file, your computer will assume that this file exists in the same folder or the same directory as the program. So if you do not want to specify a path, all that you need to do is store that file inside of the same folder where your program is located. Let's see. Now, there are multiple methods that exist for you to work with set files after you have opened them. After you open the file, there's a plethora of actions that you can perform to perform certain operations on that file. So if you want to write some data to a file, you will put that name that you have created for your file object, and then you will put a dot write. So a keyword write, and then inside of parentheses, you will put whatever you want to be written to that object with quotation marks inside of the quotation marks. Now, this is the way to close that file. Again, you will put the name that you have assigned to your file objects. Then you would put period dot close with parentheses. Nothing else, just one statement. This will close your file. Now, read methods. Read will read entire file contents into memory. So what that means is it will take the whole file and it will read the whole thing from start to end into whatever string or whatever variable you're storing it to. So the whole file will be stored as just one singular item. Now, read line is a little bit different. Read line will read just one line of your file and store it into some variable. So if you want just one line to be stored, you will use read line. If you want the whole file to be stored, you will use the read method. Now, the difference between the two modes of writing and appending. When you open a file with writing mode, W right here, writing mode, if the file already exists inside of your directory, it's going to be overwritten, which just means all of the contents of the file that have been existing before to you opening a file with the W mode, they're going to just be deleted. They're not going to exist anymore. Everything that you are putting into a file is going to be the only thing that exists inside of that file. So everything that has been stored in there previously will be deleted. However, if you do not want that to happen, you will use the append mode, A. Append mode will not delete anything that have been existing before you have opened that file. So if you don't care about the contents of a file, you will use the W mode. If you care about what was in that file before, you will use the append mode, or A. The data that you are appending to that file is going to be written at the very end after the contents that have been there previously. Now, numbers. One thing to know when you're working with files in Python is that everything is going to be stored as a string. No matter if it's a number, no matter if it's a decimal, doesn't matter, it's going to be stored as a string when you retrieve it or when you're writing it to it too. So it's going to be just strings. It's not going to be integers, it's not going to be floats. It doesn't matter to your computer because everything is going to be stored as a string. However, if you do not want that to be the case, you can change the format of those strings that you're retrieving from a file. So if you are retrieving numbers, for example, integers, you will just have to put int in front of whatever you're retrieving. And I think there is an example of it somewhere. Basically, what's going to happen is you just need to put int and then put the string that you have retrieved inside of the parentheses. That's how it's going to work. Or again, float. Float is used for decimal numbers. Again, you will just put the string that you have retrieved from a file right here. Right now, you will not be working with files that contain a lot of data. However, moving forward, after you graduate from this program, you will be working with very large amounts of data. And you won't be able to just retrieve it by hand. You will have to use loops to retrieve that data, to retrieve those records, items from your file. And to do that, this is how it works. This is the flowchart to how to retrieve all of the contents of a file. So first, we're going to open the file. Then after that, we're going to use read line to read the first line from a file. Again, remember that read line is a method that exists in Python for us to read just one line from a file. So we're going to read just one line, and then we're going to check if the read line returned an empty string. Because if the read line returned an empty string, that means we are at the end of our file, right? Because usually in a file, you will have things stored right after the other. And then if your read line sees that there's absolutely nothing left inside of that file, it's going to return an empty string. Now, if it did return an empty string, we're just going to close the file. We're going to go to our last step because we reached the end of the file. If it did not, we're going to follow this arrow right here. We're going to process the item that we just read from a file. We're going to store it in a list or in an array. Doesn't really matter. We're going to store it somewhere, and then we're going to use readline again to search for the next line that exists inside of a file. And then we're just going to go all the way back to, I have no idea where my mouse is bugging today. I apologize for that. Then we're going to return to the very beginning of our loop. And this process will continue until your read line returns an empty string. There is a for loop that exists in Python, which is very useful when you're working with files. And all that you have to do to read the whole file, to read all of the contents of a file, you have to put the keyword for, which stands for the for loop, beginning of our for loop. Then you have to specify a variable such as line or read line, doesn't really matter what the name of this variable is. Then you have to put the keyword in and the variable of the file object that you have created. So after you open the file, you're going to have a file object. And after that, you can perform this for loop. So for some sort of variable in whatever file you want to open, then you will put a colon, and then you will put whatever you want to do with that line. And this loop will go through every single line that exists inside of your file. Let's see. With statement is very useful when you're opening a file because it will automatically close it for you. So remember I showed you that there's a statement to close a file. Well, if you're using the with statement, you do not have to do that. You do not have to write that line. So all that you have to do is put the keyword with, then the keyword open, the name of the file that you want to open inside of the quotation marks, and with which mode you want this file to be opened as, and then you will have to create your file variable. So after you do that, you put a colon, and then you will put whatever you want to do with that file after it has been opened. Now, again, a couple of reminders. File name will specify the name of the file. There are only 3 modes that you can use, R, W, or A. And file variable is going to be the variable that will reference this exact file that you have opened. Here's an example. We're opening a file called myfile.txt for writing. So I see that we're opening it for writing, and that tells me that it is an output file, and we are going to be writing something to that file. And again, as we're opening it as output file, and after that, we're just going to specify what we want to do with it. See, we do not have to write any statements after that. this whole clause, the with clause, will automatically close that file for you. So it is very useful. Again, this is the same idea. Instead of opening for writing, we're opening for reading. And as you can see, we are changing the name of our file variable. We're changing it to input file because we're reading input from that file. You can also open multiple files if you want to. They do not have to be the same type. They do not have to be opened for the same mode. It doesn't matter. The only thing that you have to be careful is naming the files accordingly. So if you're opening a file for reading, make sure you name it some sort of input file or input file 1. Doesn't really matter. Just make sure that you differentiate the two. And if you're opening it for the writing, you have to specify that it is an output file. Just because you won't be the only person working on your programs later on. So this is just a way to make sure that everybody's on the same page, every single person that's working on the program at the same time as you. The only thing that you have to do is separate the two files with a comma. Records, processing records. So think of records as a table. If you've ever seen Excel, you will know that in Excel, it's all stored like this, right? There's a rectangle and these are fields. So think of the record as one line. So this whole line is a record and field is just a single piece of data. So this is the first field, second field, third field, fourth field, and so on. And this is record number 1, record number 2, and record number 3. So in this little rectangle that I drew, we only have 3 records, but we have this many fields. Each small rectangle represents a field. You will also know more about how to work with records when you move on to the SQL class, because in SQL, you will be working with databases and diagrams and stuff like that. So you will know exactly how to do all of these actions: add records, display records, search for specific record, modify records, delete records. Exceptions. Now, this is the second part of this lecture. Exceptions are very useful when you are debugging your code. So if you know that if you are expecting some errors in your code, or if you are expecting that an error might occur, this is where the exceptions come in. So exception is just an error that's going to occur when your program is running. Your program will usually, if you have an exception, your program will usually just stop executing and gonna throw some sort of message at you, like error at line 57, something like that, like input mismatch. There's a lot of types of error. So it's going to tell you the type of an error that is happening and at which line that error occurred. And tracebacks are when the computer is telling you where that error occurred. Now, you can prevent a lot of those exceptions by just thinking and designing the program in the right way. That is why the design of the program is very important, because the good design is beneficial to not having a lot of exceptions, and then not spending too much time on debugging and fixing those exceptions. Now, one of the examples is input validation. Remember, we covered those. We covered the input validation loops. For example, if the user needs to type a name and they enter a number, that might cause your program to stop executing because your program does not accept a number. But you can prevent that from happening by making sure that if the user enters a number, that you do not let the user just get away with it. You're going to ask the user repeatedly to enter a name, enter a name, enter a name until they enter a string. There is such a thing called exception handler. Now, those are very useful because these will not cause your program to crash. If you create an exception handler in Python, it's a try except statement. So try some code that you want to be tried, and then you will put except and the name of the exception that might happen when you're executing this code. Now, in this case, your program will not crash, but it will send a message to you. So it will send the message saying if the exception occurred, it's going to send some sort of message saying that you can actually specify which message is going to be sent if that error occurs. But it will not cause your program to crash. This is why it's so great. Instead of crashing the program, you can just move on with your program. However, some sort of statement is going to be printed like an error occurred here, but the program will not crash. Let's see. And oftentimes, inside of your try block of code, you can check for multiple exceptions. So if you do not want to check for just one type of exception, if you want to check for multiple, you can do that. You will just have to specify all of the except clauses. So for each type of the exception, you will have to have the except clause. So like the same idea as here, you see except exception name, you will just have to put multiple of these if you want to test for multiple exceptions. Let's see. Sometimes your try except statements will include the finally clause. And finally, what that's going to do, it's just going to execute if it's going to execute, it doesn't matter if the exception occurs or not, finally will execute in any case. And this is just a way to clean up your run before exiting your program. So for example, if you are trying to get some input from a user and then there is an exception that occurred, for example, they typed a number and you're expecting a string, you will throw an exception saying that the user entered a number instead of the string. And after that, you can specify that you got some sort of input from the user. So if you want to make sure that an input has actually been retrieved from the user, you will put it in your finally statement. So right here, you will put input has been retrieved from the user. Let's see. Now, if your exception was not handled, or for example, you did not think that an exception might occur, but some sort of exception will occur, your compiler Python will show you which exception that is, which type of an exception happened. And after that, after you see that, you can go back to your program, go back to your code, and make sure that you are trying for that exception, that you are checking if that exception has occurred. So it's really simple. It's really simple to try your code for more exceptions. You just have to add another except block, and that's pretty much it. If you did not think of an exception, there's no big deal about that. Your compiler will make sure to tell you that there is an exception and you have to test for that exception. All right, that is